the third video on the playlist about named reactions. So in this video, we'll be discussing about Wutz reaction, Wutz Fittig reaction, as well as Fittig reaction. The reason I put all these three together in one video was because of the fact that they're actually quite similar, and instead of learning them separately and memorizing or understanding and memorizing three different things, you might as well do it in one go, and that way it just makes more sense. So Wutz reaction, the first one, is an alkyl halide. When it is treated with sodium metal in dry ether, it gives a higher alkane. So here you have an alkyl halide Rx, okay, and this is going to react with sodium. Okay, for now let me just remove the sodium and another molecule of the same compound is reacting in dry ether. The word dry ether is very, very important, and this leads to the formation of an alkane, a higher alkane. And the reason, okay, and one more thing, this is a coupling reaction, which means two carbon atoms are forming a new bond. Basically, two molecules are going to combine to form a new bond between them. So here what's happening is this is going to get removed, and that's why we put 2NaX. Okay, so this leads to the formation of RR plus 2NaX. So in this reaction, what we are observing is that an alkyl halide is reacting with in the presence of sodium to form an alkane and the sodium halide. So the reason, again, let's come back to this dry ether. Dry ether, that word is very important. We know sodium in water. There are so many YouTube videos when sodium is put into water, it is quite, the reaction is very explosive in nature. So it has to be stored in kerosene. So the reason we use dry ether, and specifically dry ether, is because generally ether might have some amount of water in it, but dry ether is devoid of any water molecules. Even a little bit of water will lead to this burning up. And there are other reasons why we are using dry ether specifically. One of them is alkyl halides have to be dissolved in the solvent. So if the alkyl halide is not soluble in the solvent, then the reaction wouldn't take place in the first place. So because of that, we're using dry ether. Also, if you remember when we talked about Finkelstein's reaction, we learned that the variation in solubility of the sodium halide makes sure the reaction goes forward. So in this also, sodium halide is insoluble in dry ether, and that makes sure it's easier to separate the sodium halide formed, and so you'll only be left with an alkane in the reaction mixture. So another example, we'll be doing like two other examples. So let's take bromomethane is going to be reacting with two molecules of sodium. So BrCH3 in the presence of dry ether to form CH3, which is an ethane. So there's a new carbon-carbon bond formed, plus 2NaBr. Let's take another one. If suppose we are using C2H5, which is ethyl bromide or bromoethane, it's going to lead to the formation of C2H5. This is nothing but butane plus 2NaBr. Now, hypothetical case where we have two different alkyl halides. In that case, we'll have we'll have three different products which are formed. So Rx plus 2Na XR double dash. So these are two different groups. So this could be a methyl, this could be an ethyl, but they have the same halogen group, that is. So this leads to the first probability is them forming, the same molecule So R double dash plus and R double dash plus R dash R double dash plus NaX. So basically, Wutz reaction, we are reacting a molecule, the same kind of alkyl halide is going to react with sodium to form an alkane, and this is a coupling reaction. The next reaction we are going to be learning about is Wutz Fittig reaction. So Wutz Fittig reaction is similar to Wutz reaction. So I'm going to leave this here. So then this one is called Wutz Fittig reaction. So this is also going to be a coupling reaction. That's how we're learning all of them together. So in Wutz Fittig reaction, the main difference between Wutz and Wutz Fittig is the fact that you have an aryl halide in this case. So this means here you have two of the same molecule. In this case, we'll be having a different one. So you'll be an aryl halide, okay, is it reacting with sodium, again sodium, and an alkyl halide. So an aryl halide and an alkyl halide are reacting with each other in sodium and dry ether. Okay, so again here also it's dry ether to form an aromatic compound. So here your other compound is, another product is 2NaX. So if you notice, the similarity is actually very obvious. So here you have, instead of an R, we are using we have an aryl halide, which means this particular reaction is a Wutz reaction, this one. And if we replace the R with an aryl group, then it becomes Wutz Fittig reaction. So here also this is going to get eliminated. Okay, another example. Let's for example take chlorobenzene reacts with 2Na in the present, and we are reacting it with chloromethane in dry ether to give us toluene plus 2NaCl. So this is an example of a Wutz Fittig reaction. The last one we are going to be learning about, the last named reaction of this video, is going to be Fittig reaction. So again, this is a coupling reaction. So Fittig reaction is also a coupling reaction, and this is going to be similar to our Wutz and Wutz Fittig. And here, so first case we had two alkyl, an alkyl halide. The second case we had an alkyl halide as well as an aryl halide. In the third case, we are going to be having two aryl halides. So these two molecules of the aryl halides, halide is going to be reacting with sodium in presence of dry ether to form biphenyls plus obviously 2NaX. And an example for this could be, let's take chlorobenzene reacting with Na plus chlorobenzene, another molecule of chlorobenzene in the presence of dry ether to give us biphenyl plus 2NaCl. So that is all about Wutz reaction, Wutz Fittig reaction and Fittig reaction. So basically Wutz reaction is the reaction of an alkyl halide with sodium in dry ether to form an alkane. So if we are taking only one alkyl halide, it is Wutz reaction. If you are taking an alkyl halide and an aryl halide, it's Wutz Fittig reaction. And if we are taking only an aryl halide, it becomes a Fittig reaction. Do not learn these three separately. You're just wasting your time. You understand them as, as they are right now. It'll be much easier for you to basically do this in your, or rather remember this for your exams or tests or whatever, whichever that you're preparing for. So with that, we're done with Wurtz reaction. The next one we'll be learning about Friedel-Crafts reaction. Do check it out.